Hello everyone, my name is Chirag and I welcome you all on the behalf of PyNet Labs. I welcome you in this video, and in this video we are going to talk about something which is very much important in the internet. That is your IP address. We will have the introduction to the IP addresses, the internet layer which is your layer 3, and then we will also see how IPv4 addressing works. So first of all, IP stands for Internet Protocol. The Internet Protocol is very crucial because the entire web keeps running over it. So we cannot imagine internet without IP addresses. IP is protocol, or we can say a set of rules for routing and addressing packets of data so that they can travel across network and arrive at correct destination. Now you simply go onto your browser and you type google.com. Basically you are just pinging the Google server from your device. There is somewhere between communication between your PC and your Google's server, and this communication is happening because of the IP addresses. So we can simply see that how much it is important to us. Then data traversing the internet is divided into smaller pieces, which is called as packets. It works on layer 3 of the OSI model. Let's move ahead. Now these IP addresses can be converted from the dotted decimal form, in which we usually see the IP address, to the binary form. Now binary numbers are, we know, composed of zeros and 1, whereas when we talk about the decimal numbers, they are there from the range of 0 to 9. So let's understand how we can convert any IP address into the binary form or vice versa. So we'll simply use this formula, which is required for converting any IP address into its binary form. Let's take a random IP address. I'll take, let's say, 192.168.1.10 as the IP, and I'll just try converting into the binary form. So how do we do that? First of all, we will create this value 192. So I can simply see that 192 can be created by adding 128 and 64. If you add them up, you will get 192. So I will keep 1 here and 1 here, and the rest of the bits will be kept as 0. We are converting it into the binary form. So we have taken 1 for the values which we want and zeros for the one which we like, for those values which we don't want. Then after that, I need to create 168, which will be 128 0 plus 32. This gives me 160 0 plus 8. This gives me 168, and I'll keep the rest of the bits as 0. Then for 1, it is pretty much easy that we will have 0 0 0 for all of the starting bits, and the last one will be 1. Then for the 10, we can take 8 plus 2, right? So 0 0 0 0 1 0 1 0. Now we can simply say that the binary conversion of the IP 192.168.1.10 would be like 110000.1010100.7 times 0 1 dot 4 zeros 1010. There you go. This is your binary conversion of your IP address 192.168.1.10. Just like that, you can convert any IP address into the binary form. You can also try doing this, and you can discover this formula. Then an IPv4 address, how is it represented? We just tried the 192.168.1.10 IP, right? So we can see that there are 4 groups which are being separated using these period signs, or we can say the dots, right? So these are called as octates. This is your first octate, this is your second octate, this is your third one, and this is your fourth one. So an IP address is the unique address which is used to identify each device, be it computer, be it mobile, your smartwatch, maybe your laptop, or any device which requires IP address. Then it is a logical address which is used to identify the host in a network. It is also a unique identifier. So the total bits are 32, which means there are 8 bits in the first octate, 8 bits in the second one, 8 in the third, and 8 in the fourth. Each octate is of 8 bits. So this makes the total size of IPv4 address into 32 bits. Then this form is your dotted decimal form. The one which we tried before this was your binary form. If we talk about the one which we have calculated here, this one, this is your binary form. Then if we talk about the size of IPv4 in the terms of bytes, then it is of 4 bytes. Now this is the IP structure. As we have already talked about this, let's quickly read and understand this again. So there are 4 octets of 8 bits. IP address consists of 4 sections. Each section is 8 bits long, and in decimal, each section can range from 0 to 255. That means the IP range can be there. Inside the one octet, the values can range from 0 to maximum of 255. You cannot put a value of 270, let's say, inside any octet. Then these 4 parts of IP are known as octets. Combination of 8 is octet. So that's why we call it as octet. This is your dotted decimal notation, which is represented with the decimals and some periods, right? Then this is how your IPv4 header look like. This we can say these are the different fields which we have inside IPv4 header, and these are attached with the data and is taken ahead with the from one device to the other. So let's understand them one by one and let's see what do they mean. All right, so the very first one we have here is version. This version defines that whether the IP address is of version 4 or 6. Simply, so if we are having it as version 4, then the decimal value is going to be 4 here. Then the next thing we have is h length. This h length means the header length. The header length is a 4-bit field which tells us the length of IP header. Then the next thing we have is type of service. This includes, basically this is used for quality of service. This is how, using this field, you can prioritize some sort of packets so that they don't have to face latency or they don't have to get inside the queues. Then the next thing you have is total length. This is a 16-bit field which indicates the entire size of the packet. Now this entire size means it includes the size of the header and also the data. Hence, it can vary from the range of 20 bytes to maximum of 65,535 bytes, depending upon the data, right? Then the next thing you have is your identification. It is the unique ID, or we can say it is the identifier. In case the packets get fragmented, then the next packet which will be generated will have the same identifier. So if the packet is getting fragmented, then each packet will use the same 16-bit identification number to identify which IP packet they belong to. Then we have some IP flags. These are some 3 bits fragmentation. These are like the values which are used for representing the fragmentation of the packets. The first bit is always set to 0, then the second bit can be DF, and the third one can be MF. DF means that the packet cannot be fragmented, which stands for don't fragment, and MF is more fragments. That means the packet is said to be fragmented. Then the next thing you have is header checksum. This is a 16-bit field which shows the checksum value and can be used for checking the errors in the datagram header. Then you have the source IP address or the IP address of the PC which is sending the packet. Then you have the destination IP address, which is basically the IP address of your destination PC. Then you have this option field, which is not basically used often, but we can say the length is also not defined, as it can vary upon the options you are using inside it. And the information such as source root or record root are used here, and the network administrator sometimes use this option to check whether a path is working or not. So this is how your IP header work together with these fields to make the data transmission possible. Now, the next thing which we need to know about IP addresses would be these different classes of IP address. So when we talk about IPv4, we have 5 classes here. We have class A, class B, class C, then class D and class E. These 5 classes are provided to us, but out of these 5 classes, we can only use class A, class B, class C, not the class D or not the class E. These are reserved for the multicasting purposes and for the research purposes. So the range of IP in the class A is from 0 to 127. The distribution of the network and host part would be like this. The first octet is there for the network part, then the rest of them is there for the host part. Total networks which I can get out of a class A would be 127. Then the total host is somewhere around 16 millions. Then 127.00 network is reserved for the loopback addresses, which is basically the address used by a device, or we can say used by the PC itself to check the connectivity with the TCPIP stack. Then class B ranges from 128 to 191. The two octets are there for the network part, and then 2 are there for the host part. We can get 65,536 networks out of class B and 65,534 addresses out of class B. Here also we have this range, which is used as a PIPA, which stands for automatic private IP addressing. In the case when DHCP fails, a PIPA is the address which is assigned to the PC. So this is not something which we can use from. Then class C is there from 192 to 223, which has the 3 octets as the network part and the last one as the host part. 16 million networks can be taken out of class C, and the maximum addresses which we can have from a class C network would be 254. Then, as we have already discussed, that class D and class E, these are not available for use. These are reserved for multicast and research purposes. So I would say this much introduction to IP addresses would be enough to move ahead with the subnetting or the configurational things. I hope you guys got to learn out of it and you enjoyed the video. I'll see you in some other video. Till then, take care. Make sure that you study about these topics and you read about them. Till then, take care. Bye-bye. Thank you so much for your time.